This is the recommended layout for the diodes and rectifier lab. So we have here our transformer. This side is the primary side connected to the mains, and this is the secondary side. Make sure that there's some space between this transformer and this board. Here, this is the grounds connected to the center tap of the transformer, and we have this diode with this polarity here. So make sure that everything is fixed in place and everything lay flat to the table. Your table is clean, no messy stuff, nothing hanging from the top of the shelf. And the final thing to check is the continuity. So if you hear beep sound, it means that this is the same node. So we may check this same node, and then this, there's no sound here. So this is good right now. But if we use this node and then this node, we may get some sound. This is because of the transformer itself is the plain wires, and in DC the resistance is 0, but for AC there will be some finite resistance. And after all the checks, plug in. And in the oscilloscope here, we will have auto setup button. Maybe we can turn channel 2 on, auto setup again. We would like the scales to be the same, so adjust the scale. 5 volt per division, and then adjust the offset. Yep, that's it for the offset. And then this is the half bridge rectifier. No, we will have no wave here. And then we may try to measure DC volts. Of the output, here DC volts and AC volt. Of the output, AC volt. To make any change to the circuit, unplug this for safety. And then we may change to the full bridge by unclipping here. And we combine all the signals here. Clip it back again. Done. Right. Maybe final check of the continuity. This and this. Okay. Fine. No sound. Good. Next thing, after all checks, plug in. This is the full bridge. The next thing we can do is we can try to measure DC volt. DC volt, AC volt, AC volt. We may try to put in some capacitor across this load, and for safety, unplug first, put in capacitor, here, this point, 2 point, and then we may plug back in. We may zoom in to see the waveform if needed. And then measure the voltages. DC volt, AC volt. AC volt. And after that, if you would like to make further change, still. And after that, we may measure the ripple. So channel 2 coupling go to AC. And then we may try to set up the trigger. The source to channel 1. Yep, so it triggers at channel 1. And then for channel 2, we can measure the peak to peak voltage using the cursor function. And then after all the measurements is done, unplug, change the value of resistor to a bigger value. Change the value of resistor. Here, plug in again. And now we may see, we may return this to DC coupling. Same magnitude, same offset, so that we know that this is ground, right? And here we got nearly DC signal with ripples. And with this, we may also measure the ripple by setting the coupling to AC. And then we may enlarge this a bit and use cursor to channel 2 and then measure the ripple. Ripple delta V around 3 volts. Yep, and we may use what? This voltmeter, 15 volt, AC volt, AC volt only 2 volt. Good for us now. And the next thing we would like to do is to put the regulator in. So the same thing, unplug. And the leftmost is the input and the rightmost is the output. The ground is in the middle. And we may see some dangerous thing here. If we directly connect it like this and connect the ground here, we may got some short. So we recommend you to place the ground here and the back and place it toward this breadboard. Connect the ground here and then change the load to this output. Plug this in again. Right. And final continuity check here. So this and this, right? And then the output. Okay, good. Ground. Yes, ground should have some beep. Now, if you make some mistake, for example, you don't know the pins, right? Then, if there's beep here or beep here, it means that the pin is not at the ground. The wire is not at the ground. So you have to make sure that the wire to the ground is at the ground pin. Test again. Yep, ground should beep. Ground should beep. right? This should not beep and this should not beep. Good. Now make sure that all the connections are locked again. So in case it's not locked, maybe we can try to make it hold in place. Or we may move it a bit. This should be in place now. Make sure the table is clean, nothing else on the table. Plug in again. Yep. And for channel 2, maybe we can change the coupling back to DC. And then yep, at the same voltage per division. And here 5 volt, we got 5 volt signal for the ripple. Go back to AC, then zoom in. This is our ripple now. Because of the regulator, we got very low ripple. Then you may use the measurement function again to measure. Use cursor. Here, ripple is quite low now. And we may also measure DC volt at the output. Output was 5 volts, AC volt. Oh no, this 1.1 millivolts. Or maybe we can measure the voltages at this input stage. So at the input, AC volt is 0.9 volts, and DC volt at the input was 16 volts. Okay, great. And this is all about the measurements using this transformer. And when you have done all the measurements, unplug this like that. And we may proceed to the next experiment of this voltage regulator.